All right, guys, we're going to do the notes on joints today. So if you'll get your stuff out and get ready, we're going to go through the first part of joints, but we are going to stop before we get to joint movements and joint motions. I'll do those on Tuesday after our bone marking quiz on Monday. Okay, so another name for a joint is an articulation. And again, a joint is just where two bones come together. Any two bones in the body that meet will form a joint. Some are more traditional, or what you might think of as a joint, like a ball and socket, for example, where the head of the femur goes into the pelvis. But other ones are not as obvious, and an example of that would be like the cranial bones coming together to form a suture, or even where your radius and your ulna join, there is a membrane that runs between those two, which connects two bones, therefore it is called a joint. All right, so the first thing we're going to do is classify joints that are immovable, or classify joints based on how much movement is allowed between those two bones. The first one is an immovable joint, and the other name for an immovable joint is a synarthroses. The name is synarthroses because it is immovable, but in structure they are fibrous joints. So the function of the joint is immovable. The structure of the joint is fibrous because it is brought together by fibrous connective tissue. There are three examples of immovable joints. The first one we'll do is a syndesmosis. And a syndesmosis is where you bring two bones together with a ligament structure, most of the time called an interosseous ligament. You will have an interosseous ligament between the radius and the ulna and the tibia and the fibula. Okay, so let's look at these bones right here and review for just a second. I know this is the tibia because it is the thicker bone on the bottom of my leg. I know this is the fibula because it is the fine bone. If we look at this fibula, we have the head of the fibula. We have the lateral malleolus down here at the bottom. On the tibia, we would have the medial malleolus. We'd also have the anterior crest of the tibia running down the front, what you would call your shin bone. And then the tibial tuberosity would be right here. And this little, what we call the mohawk on top of the tibia would be the intercondylar eminence on that tibia. The tibia and the fibula are connected to one another by this interosseous ligament, which forms a syndesmosis. It is an immovable joint. These bones do not move around each other. They do not rotate. They do not bend. They do not flex. They do not extend. They are stuck together by this interosseous ligament. The same thing would be true for the radius and the ulna. If I look at the radius here, I see the head of the radius, the radial tuberosity, the styloid process of the radius, and it is joined in or joined to the ulna by this interosseous ligament. Remember, we've got the ice cream scoop on the ulna. That is your olecranon process. The inside of that ulna is the trochlear notch. And then here, this very small V-shaped prominence would be the coronoid process on the ulna. Okay, so for Monday, remember, you got to know all of those bone markings. Right now, I'm kind of doing a review as we go through these joints as well. Okay, so again, syndesmosis is how we bring two bones together using an interosseous ligament. The second example of a synarthrosis, which is an immovable joint, is a suture. Okay, and we did sutures when we did the skull, coronal suture, squamous suture, lambdoidal suture. It is where the cranial bones will come together and fuse with a fibrous connective tissue. Eventually, that fibrous connective tissue will ossify or become bone, but that takes a while. Okay, we know when the fetus is born, they have the soft spots or the fontanelles, which would be a separation of those cranial bones that will then become a suture. The last example of a synarthrosis is a gomphosis. Okay, a gomphosis in the body would be where the teeth connect to the jawbone, whether that is the maxilla or the mandible. How that tooth connects into the jawbone creates a gomphosis, which is an immovable joint. Okay, you will lose your baby teeth, your primary teeth, but that is a little bit different. It's a gomphosis, but as you age, the roots of that tooth will break down when the permanent teeth are growing. And the permanent teeth are more of an example of a gomphosis, which is an immovable joint, again, called a synarthrosis between the maxilla or the mandible and the tooth. Okay. Here's a picture from Body Worlds. You can see here the leg bone, the leg muscles rather, have been removed. And this is the tibia. You've got the fibula on the backside, and you can see the syndesmosis between those two bones. Here's another image of the radius and the ulna. The light was shining through this syndesmosis, and I thought you could see it really well, which is, again, just a piece of fibrous connective tissue that runs between the radius and ulna to hold them together. The next type of joint that we'll go through is not immovable, but slightly movable. Slightly movable joints are also called amphiarthroses, and they are cartilaginous in their structure. Okay, cartilaginous can either mean typically hyaline cartilage or fibrocartilage. You don't normally join bones together using elastic cartilage. Remember, hyaline cartilage is our most plain cartilage, not very obvious fibers there, but with fibrocartilage, you'll have a lot of collagenous fibers for the shock absorption. Okay, there are only two examples of amphiarthroses, which are slightly movable joints. The first one is a synchondrosis. If we look at the word, syn means together, conj means cartilage. So you are bringing two bones together with a piece of cartilage. Two examples here would be the costal cartilage, which joins your ribs to your sternum, and the epiphyseal plate is an example of a synchondrosis because you are using a piece of hyaline cartilage to join the epiphysis of a bone with the diaphysis of a bone. Still not your traditional joint. I would not think of this as a joint, but it is, because it is where two bones or two pieces of a bone in this example are coming together with a piece of cartilage. Okay, so synchondrosis, two examples, costal cartilage and epiphyseal plate. The next example of an amphiarthrosis or slightly movable joint is a symphysis. And there are two symphyses in the body that we'll need to learn. You already know both of them. The first one is the symphysis pubis, which is where the two pubis bones of the pelvis are brought together with a strip of fibrocartilage. The other example are your intervertebral disc that are running between your backbones. In a symphysis, most of the time it's going to be fibrocartilage. If you look at this picture from Body Worlds, I can see the body of the vertebrae here that are more, tan or yellow in color. And then in between the vertebrae, you will have the intervertebral disc that is very white in color because of all of the collagenous fibers in that fibrocartilage. So here, how do you memorize it? Well, first I start with the fact that a slightly movable joint allows a little bit of movement, not a lot, just a little bit. Another name for slightly movable is an amphiarthrosis. How do I bring the bones together with some form of cartilage? Your examples are costal cartilages and epiphyseal plates. Those are hyaline. Examples of a synchondrosis. Examples of a symphysis are brought together with fibrocartilage and is either an intervertebral disc or the symphysis pubis. All right, guys, we're going to finish the notes. I'm sorry that I have to do this as two separate videos, but I had to do one earlier in the morning, and now it's 5 o'clock, and I'm finishing it. So let's go through the rest of these bone notes real quick. So the last type of joint is called a freely movable joint. And the name for a freely movable joint is a diarthrosis or synovial joint. So your first type of joint was a synarthrosis, and those were fibrous in structure. The second type was an amphiarthrosis, and those are going to be cartilaginous in structure. And now we've got a diarthrosis, which is going to be synovial in structure. On this picture, and I probably need to zoom in a little bit because I think you have to fill in some of the notes or some of the words here. But on the picture of this joint here, this can be the end of any two bones that come together in a diarthrosis. And the end of that bone is going to be wrapped in articular cartilage or covered in articular cartilage. And that articular cartilage is going to blend right into something called the synovial membrane. And the synovial membrane will make synovial fluid that will fill this joint cavity. And the joint cavity is filled with synovial fluid, again, made by the synovial membrane. And the outside of this joint is covered in a joint capsule. The ligaments would be right on top of that. That joint capsule is dense, irregular connective tissue. Remember that articular cartilage is hyaline. And then within that joint space or joint cavity would be the synovial fluid. All right, if we look at this picture here, this is a basic structure of any freely movable joint. And we'll go through the numbers here. Number 1 is a joint cavity. That is the space found between these two bones. The outside of the bone is held together with a ligament, okay, and that ligament and joint capsule can also be kind of the same thing, really. The joint capsule goes under the ligament holds the bone to the bone, and right under that would be the dense, irregular connective tissue called the joint capsule. The ends of the bone are covered in articular cartilage, which is what appears more white right here. And that articular cartilage, again, will just kind of turn into the synovial membrane, which is going to make the synovial fluid. This is just a picture of spongy bone versus compact bone. When you pop a joint, if you pop your knuckles or whatever, what you're doing is actually pushing air bubbles to the periphery of this joint cavity, and the carbon dioxide within that synovial fluid will pop bubbles within that cavity, and that is the sound that you hear as you're popping your joints. It's not really a bone rubbing on a bone as long as it is a freely movable joint. If it's in your neck, we know that that's not a freely movable joint because that's an amphiarthrosis. That is a fibrocartilaginous disc in between your two backbones. Those are not freely movable. Therefore, when you're popping your neck, you are hearing bones kind of rubbing against one another. Here's another picture, and this is just a specific picture for a knee joint. We know that the top bone of the knee is a femur, and the bottom bone of the knee joint is a tibia. Okay, we know that the lateral and medial condyles of the femur and the tibia will come together and articulate. The ends of the femur and the tibia are going to be covered in the articular cartilage. In between the knee bones, the femur and the tibia, you're going to have a fibrocartilaginous disc called the meniscus. Okay, and that meniscus is a C-shaped disc that will provide some shock absorption between those knee bones. Number 6 here in the front is the patella. Okay, and the patella is held in place by the patellar tendon on top and the patellar ligament on the bottom. The space found between your two knee bones is the joint cavity. Filling that joint cavity is going to be synovial fluid, which is made by number 8, which is your synovial membrane. And in front of that patella is something called a prepatellar bursa. Okay, and a bursa, in my mind, is nothing more than a pillow. Okay, it's a small fluid-filled sac that can be found within the knee joint to provide some extra cushion. There's another one down here that I'm circling. That would be your infrapatellar bursa because it is below the patella. All right, and now what we'll do is go through the types of freely movable joints. These again are diarthrotic or called diarthroses. They are synovial in structure. First one is going to be the ball and socket joint. Ball and socket joint example in your body will be the humerus fitting into the glenoid cavity of the scapula, or the head of the femur fitting into the acetabulum of the pelvis. Remember that femur is held in the acetabulum by the ligament that can be found on the fovea capitis on the head of that femur. Second example is a hinge joint. The hinge joint will allow for flexion and extension, and I'll go through the differences in those movements Tuesday. And you basically hinge back and forth as if you were hinging a door, open and closed. Two examples of that will be the knee joint and the elbow joint. The olecranon process will sit in the olecranon fossa of the humerus. Let me say that again. The olecranon process of the ulna will sit in the olecranon fossa of the humerus and hinge back and forth. The medial and lateral condyles of the femur and the tibia will articulate back and forth and hinge and either straighten the knee or bend the knee. Third example is a pivot joint. A pivot joint that we looked at yesterday with bone markings is how the radius and ulna articulate around each other to where you can turn your hand back and forth. You can rotate your hand at the elbow. The other example of a pivot joint is the atlas and the axis of your neck. Remember, atlas is the specific name for C1. Axis is the specific name for C2. And if you remember, that axis has a thumbs up, and that's called the dens. The atlas will sit down on that dens and allow you to shake your head no. Okay, that's a pivot joint. Next type is a saddle joint. Saddle joint is only found in your thumb. Okay, and it is the connection between the carpal and the metacarpal of your thumb, and will allow humans to have an opposable thumb. An opposable thumb means that I can touch my thumb to every individual finger, and allows for movement back and forth, no rotation, but back and forth, and I can touch my thumb to my index, middle, ring, and pinky finger. Condyloid or ellipsoidal joints, they are found in your knuckles. That's how I think about it. So it's the connection between your metacarpal and your phalanges joint. Could be metatarsal and phalange as well, so toes or fingers here. Knuckles of your hands and knuckles of your feet. Gliding or sliding joints, those names are synonymous. And these will allow for bones to slide against one another. Maybe just a little bit of rotation, but not a whole lot. Okay, these are going to be your intercarpal joints, meaning between the carpals of your hand or between the tarsals of your feet. All right, so this next series of notes and information, I'm going to do this on Tuesday. It won't take me just a second to go through all those. So what I want you to do now is to go through your packets of information on bone markings. When you walk in on Monday, you will have no study time because we will need the whole hour and a half to do our lab practical. I have hung the keys to the bone marking reviews on the board. Please put them back on the board so every class has an opportunity to take pictures of it. I've also posted them on It's Learning. If you have any questions, you can send me a message on Remind or you can email me and I will be glad to answer it. But again, no study time on Monday, so you need to walk in ready to go for the bone marking test. I think I may have called it a quiz, but it is a test. The last test of the 9 weeks, so we need to finish strong. Hope you all have a good weekend. Let me know if you have any questions.